So if you haven't already, now might be the time to ask yourself, if I look back at my lab notebook in 3 months, will it make any sense? You must have the basics, right? Date, title or description of what you're working on that day, protocols and what happened, and raw data. Repeat after me. Everything goes in the lab notebook. Here's some things you might not have considered yet. You've got to label your raw data. It has to include units. Once you've written the procedure down, you can reference it over and over by numbering your pages or referencing a date that you first did that procedure. Include your calculations for dilutions or making solutions and give a description of what those calculations mean. Don't just have numbers, scrawled or scribbled across the page with no units and no description. Include how you made the solutions, how were things stored and for how long between, your collection of your sample and testing it. And some other things like what equipment you used that day or what type of water you were using or what lab consumables you've used. What was their expiration date? There's so much you can add to your lab notebook. And all of this, you're writing everything down because when you analyze your data, any event may only seem out of the ordinary after you've analyzed your data, because that's the point at which it helps you explain something weird or something that seems off. So you want to write everything down. Assume you won't remember anything. Even if it seems like the equipment is working perfectly, definitely if it seems like the equipment is failing or something went wrong, write it all down. Note your failures. Note your lessons learned. Note that it was a great day, and everything seemed to work perfectly. Write it down. Within your lab notebook, your raw data needs to be organized. You can put it into an electronic format, but you need to print or paste or tape that into your lab notebook. So when you're organizing your raw data, you need to think about your number of trials and your levels of independent variable. Consider leaving room for observations. Definitely define your units. Use a table, label your units. So that can be like parts per million, absorbance, counting organisms. Since you're working with organisms, you might want to consider reproduction rates, mortality rates, or even time for 50% of the organisms to be affected. And then make that data hard to miss. So put it in a table, label the table, draw a line under your table title, have a digital version and print it each time like I was discussing before. There's a couple ways to keep these tables organized, and I'll go into more detail on the next few slides. But you can organize by independent variable, just have a simple table for each of your, things that you're looking at. Or you can enter all your data for each data point, kind of like the massive data sets that you'll see online. It's very similar to a Google form output, so it makes it great for citizen science or any kind of project where multiple people are contributing to the data set. It's just very easy that way. But, it creates a little bit more difficulty on the back end to get it organized. Once you've decided how you want to organize your data table, let's take a look at what it might look like by independent variable. So you would keep things organized by your independent variable and only put numbers into the spreadsheet cells, right? Please don't type your units every time. You want to be able to make your life easier and average these later. If you need to note multiple things about each data point, put that in a separate table. So have a simple table for each thing. So for example, if you're collecting E. coli and total coliforms and pH, you'll have a simple table for each one. That way, if your main IV is various sample locations, then instead of distance to the light here in our sample table, you would have, these various location A, location B, location C, and then you'd have trials of E. coli counts, and you'd have trials for your total coliform counts, and you'd have trials for your pH. Once you get one of those tables formatted, you can copy and paste. This is very old school, but you need to kind of do what works for your brain. So here I have trials across the top and IV levels down the side. You may not love this format anymore because, again, it's not like what like Google Forms puts into a spreadsheet or anything like that, but it does make it very easy to calculate averages and standard deviation and some of your other calculations that you're going to do later on. If you decide to go with the option that's more common in the research world, you're going to have each data point entered into the spreadsheet separately. So first you'll have an identifier like stream, and like then you can have site A, site B, site C in those categories. So here you can see like it was supplement, and then there's control and super grain and super sup and agrimore. So they have all their various levels of their IV, and then you're seeing a little bit about diet and gain, which is probably in mass. And again, they kept this very, very simple because it's being fed into a program. But somewhere in your lab notebook, you'd want to say what unit that gain represents. Is it grams? Is it kilograms? Etc. This is really easy to organize on the front end. You can even design yourself a little Google form that has like a drop-down menu so that you just click in the common things that you'd be entering over and over. That way they're always spelled the same way. They're always formatted the same way. But while easy on the front end, you will need a little more skills on the back end to sort and summarize. But these summarizing skills are worth mastering because you'll be ready to tackle really big data sets. So if you're curious about that, there's a lot of great tutorials online. Programs like R can slice out just the components of the data you want to analyze. It's called a subset. There's also pivot tables on Excel. They can quickly slice and summarize by all sorts of categories. Really cool for the business world. I've seen lots of examples for that. Again, like just check out YouTube. It's awesome. But for now, time's a-wasting. I want you to go into Google Sheets and design yourself a blank data collection spreadsheet for your group. Please include units. And then I will have information online for how you can share that spreadsheet with me and with your teammates. Grab those protocols you haven't copied into your lab notebook yet and write them down. So take this information and do something with it. Note the source of your protocols. Are you using a protocol from Hawk or from Carolina Biological? Some of you are using Vernier probes, so you can Google, or if you can't find the instructions, you can find those instructions for use and calibration if you're using a probe, and any of your tech components as well. All right, so good luck with that, and I hope this is helpful.